Alright, let's look at T1. If you notice that my displacement is down, because that's what they're saying, exactly used to lower 5 meters, so displacement is down. The piece of this T1 would have to be parallel with the displacement. So that force is directed upwards, and I only need the piece that's parallel with it. So work equals force times distance times the cosine of the angle. The force is that 1830. Newtons times my 5 meters, they gave us that. And cosine, now what is my angle? Well, this is a 90-degree angle, and then 60 more would be 150 degrees. So let's throw that in our calculator. 1830 times 5 multiplied by the cosine of 150, and I get negative 7924 joules. Let's look at T2. That one's over here. And again, remember, we're going to have to mess with the angle. Work equals force times distance times cosine of the angle. My force is at 1295 newtons. We're still going 5 meters. And the cosine is 90 plus 45, which is 135 degrees. And we'll throw that in the calculator. And I'm getting negative 4570 joules. Actually, that's 4578. Oh, 4578. Alright, let's do the W, the work done by the weight. We might call that force of gravity. And that would be force times distance times the cosine of the angle. My force is 2500 newtons. It went 5 meters. And since it's being lowered, it's the cosine of 0 degrees, which is 1, so it's just 2500 times 5, which should be 12,500 joules. Woo-woo, woo-woo, and woo-woo. Bye-bye.